July 2021. This is the year that good number of people are going to remember, and remember for a real reason of sorts. The reason will be that lightning have taken a good toll of the number of people who have lost their lives in this case. Can you imagine that the number of people who are getting struck by lightning in India had been increasing? The number of cloudbursts have been increasing. The number of cloudburst related landslides has been increasing, and this is unusual, and that is what makes July 2021 as an exceptional month of sorts. It has been largely also because of whatever that you're going to see happening in Vancouver, whatever that you're going to see happening in Siberia, or whatever that you're going to see it happening in Europe, and whatever that you have seen it happening in India. That is something for the meteorologists, for the people who are following unusual weather phenomena to remember, and remember it almost forever. It has redefined the type of a climate one can go on to build on, one can go on to think of. And why is it that we're going to say that it has redefined it? Because it has been associated with some amount of an extreme heavy amount of rainfall as well in good number of places. And when we go on to say that it has been associated with it, just go on to think we are going to be talking about such type of a cloudburst which is accompanied by a severe heavy rain. And as you can go on to see it behind, the way the rainfall takes place. Cloudburst is essentially an extreme amount of precipitation of very high intensity in a limited place. Sometimes cloudburst is accompanied with hail and thunder. It's not alone. It is accompanied with both of them, hail and thunder, and which normally lasts no longer than some type of a few minutes, maybe something like 30 minutes, 40 minutes, an hour or so. Of course, it can go on to go for 2 hours, 3 hours as well. But colloquially, the term cloudburst is used to describe any type of a sudden, very heavy and brief but very unforecastable rainfall. That means something that cannot be forecasted at all. Now, rainfall rate is in this case is equal to or greater than something like 100 millimeter, like equivalent to 4 inches per hour per hour. And that means that if there is a cloudburst for 3 hours, can you imagine 1 feet of rainfall, 4 inches, that is about 12 inches, and that makes it a foot of sorts. And that means it's not going to be an equal amount of rainfall spread over the surface. That will be translating itself into something phenomenal that is going to be found onto the surface. And as you can go on to observe it here as well, it looks like that someone has opened a hose pipe from the sky. You can go on to see this column of such type of a fall. The associated convective cloud in this case, that means the cloud from which it goes on to fall, is a cumulonimbus cloud that extends almost 15 kilometers above the ground surface and reaches in the top of the troposphere. During a cloudburst, more than 20 millimeters of rainfall may go on to fall only within a few minutes. As you can go on to take a look at it once again, that is something that is seen to be believed, the amount of rainfall as if something has been falling from the sky, so much so that it can go on to disturb the water surface as well. This is one type of a cloudburst. Now, having talked about it, you understand that the definition of a cloudburst is going to be very, very specific, whatever that we happen to know. That is, if the rainfall is going to be 10 centimeters or more or above in an hour, and that is recorded over a place that is not going to be too large, 10 kilometers by 10 kilometers of an area, that is cloudburst. Internationally, this is how exactly that we can go to think of. That means add to this definition, 5 centimeters in half an hour will also be classified as cloudburst in some places. But in India, this is an anomaly. Anomaly in the sense that is, in India, this is a normal rainfall of a sorts in some places. And why is it that we're going to say it? From good amount of a definition, there is going to be a cloudburst almost every second or third day in Mumbai that is going to be taking place. and that goes on to really make it a anomalous condition in India. Now, where does this cloudburst take place? Can go to take place. Now, cloudburst can happen in a plain, in a desert, or it can happen in a hilly region as well, in all the three places. But then there is a greater probability of such type of a cloudburst taking place in a hilly terrain of sorts. And when these cloudbursts going to take place, you can go to see the scene. How is it going to be? That is on the road itself, the movement of water can go on to be so fast. And this is one type of a cloudburst rain that has been taken from Himachal Pradesh of late, very, very recently. This is the one that has been picked up, and that is essentially a product of a very heavy rainfall. Now, having talked about it, these cloudbursts take place in three places, and in all the three places, the regions are going to be different. Cloudbursts take place in some of those type of regions where there are going to be certain specific type of conditions that are going to be met. And when we're going to be talking about it, it is going to be, for example, cloudbursts happen when saturated clouds are unable to produce rainfall. That is, the clouds are already saturated and they are unable to produce rainfall. And this is because the upward movement as it goes on to take place, that is of a warm current of air, that which is warm enough and it is saturated enough and that it keeps on moving upward without actually getting itself cooled. Now then, what will happen? Raindrops, instead of falling down, in this case, the raindrops, instead of falling down, they are going to be carried upwards. In normal circumstances, these raindrops fall. Now, as the clouds are forced in low temperatures, that means a time will come when the clouds will be forced into a low temperature condition. Then new drops are going to form. New drops, of course, will form because the vapor will go on to condense into water and new drop is going to form. And not only that, that is, some of these existing raindrops that have been there, which have been unable to come down, they will also grow in size. So all in all, the amount of raindrop, the number of raindrop, the density of raindrop, the total concentration of raindrops in that cloud goes on to increase to phenomenal extent. So after a point, the raindrops become too heavy. These are going to become too heavy after some amount of a time. And when the raindrops going to become too heavy, the clouds are unable to hold it. And unable to hold it, they go on to fall. They go on to fall not slowly. They go on to fall in something like a quick flash. Quick flash means that is it's like someone has broken the cloud. Someone ruptured the cloud, and that's the basic reason why they're going to be called by the name of cloud burst, because it goes on to look like it has burst. It has shown a burst of sorts in this case. That's one condition. Then there is another one. An obstruction may force some type of a topographic accentuation. For example, this is what is going to happen. This is what is likely to happen in this case. That is, an accentuation will go on to take place here. And when we're going to be talking about such type of an accentuation, it can go on to be seen from such type of a picture. That is all the raindrops, that means the clouds happen to move themselves and force themselves towards the Himalayas. Now that is getting accentuation. This is what we're going to be talking it as accentuation. So as they go on to move along the slope, all along the Himalayas, then they are leading to formation of such type of a cloudburst in the foothill of the Himalayas or even in the Himalayas. Most of the cloudbursts in this region goes on to take place because of this orographic accentuation. So cloudbursts occur when hot water, vapor, laden winds, they can go to mix with cold winds on the surface, and this is what is happening in the Himalayan region. There is, as these winds go on to come, they are moving upwards and they are moving towards this cold region. This is a cold region, and they come in contact with this cold condition. Water, which is going to be cloud, which is going to be saturated, that goes on to come in contact with the cold air, and when it goes on to come in contact with the cold air, it goes on to lead to a sudden condensation, and sudden condensation means all of this rainwater is going to be released. There's another aspect as well. The hilly terrain goes on to aid in heated air currents to rise vertically. That is, that's again what is happening. There is all of this is the hilly terrain, and that is allowing the water, the vapor laden water, to move upwards in this case. And this happens in two ways. First is by allowing water laden winds to absorb more moisture from the Terai region in the Himalayas. So why exactly that it happens in Himalayas? It happens in Himalayas because of a specific region, and this is going to be a Terai region. The foothill is going to be Terai region. All of it is going to be a Terai region, and that is from where they're going to pick up a good amount of moisture. And after having picked up moisture, in this case, they rise. They rise. They're forced to rise, and as they rise, they become cool. As they're going to move upwards, they come in contact with cold conditions, cold air, cold peaks as well. In this case, that is going to be one of them. And the second is that the water-laden winds rise along the slope of the Himalayas, and they're forced to rise along the slope of the Himalayas in this case. And that is what exactly is responsible for making them really disastrous of sorts. So the mechanism of excessive rainfall is not unusual. Such type of a mechanism is not going to be unusual for the Himalayas. But then such type of flooding is unusual because this is an event that is taking place in one or the other region of the Himalayas. That means it has started taking place unusually right now because the frequency of such type of cloudbursts have been increasing. Now, it is not essential that cloudbursts can go on to occur only when the clouds clash with a solid body like a mountain. It's not that they require what we have said, that is, in this case, they're going to require a solid body collision. In this case, that is the Himalayas, and they collide with a solid body. This is what has been happening in the Himalayan region overall. Without it also, it can go to take place. And where it can go to take place and how exactly it can go to take place? It can go to take place when they come in contact with what we're going to be calling it as western disturbances. And when they come in contact with the western disturbances, the conditions of it are going to be very, very, very different of sorts. Now, understand that in one of these type of cloudbursts is when they come in contact with the westerlies. Now, this is the Himalayan region, and this is the place from where the westerlies are going to be coming. That's the place westerlies come. Now, these westerlies are essentially cyclonic circulations. That means they are the one that happen to be coming, and if we can go to see it from another angle, these type of conditions are such that these conditions go on to aid in a lot of ways. The air movement that is taking place here is going to be in a form of a vortex. This is the way that is the air movement goes on to take place on the top, and that's how exactly the air will go on to move in a westerly, in a what we're going to call it is temperate cyclone. So that is where the air is moving, and the air is going to be moving in this place, and that's the way that the air is moving in this region. Now, immediately, supposing this is the place where there is some type of a vortex has taken place, some type of low pressure circulation, and this is the place where the monsoon winds, these are the winds which are going to be moist, which are going to be warm, and they're going to meet. When both of them go on to meet, imagine that is when both of these monsoon winds go on to meet with the rising slope of the Himalayas, these winds are in any case rising. And if it is that they are rising, they are driven by the westerly disturbance and western disturbances. What these western disturbances are going to do is they suck them out. It's like the way that you're going to pick up certain things by straw. This is what they're going to do. And this is what happened in June 2013. In June 2013, the winds were, that is the moist winds were moving towards the Himalayas. They were rising. They have already picked up more amount of moisture. And when they have picked up more amount of moisture from the base of it, then they were rising. And as they were rising, they were sucked up by the westerlies. And these westerlies, which had locked the monsoons, so there were three things fatal that took place on that fateful date of Uttarakhand disaster, that we're going to call it a Kedarnath disaster, that we happen to be calling it. That is moist winds rising along the slope of the Himalayas and then being sucked up upwards by the Himalayas. All three of them taking place simultaneously. The result was the Kedarnath floods, one of the deadliest floods that we have ever seen taking place. It was this unusual combination that has also been responsible to an extent of causing floods in Ladakh as well, and that was in a place called Chokmagalsar. That was the name of this region. This is where this place was in Leh. And the place was getting heated. This was getting heated, and as it was getting itself heated, the air started rising. It is a complete dry region. It's a perfect example of a desert. But there was some amount of moisture had found its way into these regions, and the temperature has been rising 34 degrees of Celsius in this case, and it led to convection. It was this convection aided by again the sucking of the winds. The winds rose, and for 6 hours it was raining, and the rain was so heavy that everything was washed out. In this case, one of the worst disasters one can imagine having taken place in independent India, and that means after 1947. So that is what we're going to be calling it as the flash floods in the region, and a good number of places were washed out. So cloudbursts can go on to take place because of different regions, even in the Himalayan regions, and different type of terrains. In the deserts, cloudbursts are taking place because of altogether a different region. As you can go to see one of these type of cloudbursts that has taken place in the desert, taken from a good amount of a distance, and you can go to see a column of water falling from the cloud. That is indeed a cloudburst. And you can imagine that the whole of the region, desert region, is going to be devoid of rainfall, and only a small column is the one that is going to be receiving such type of rainfall. Only a small column, not the whole of this region. And that goes on to make it completely unique of sorts in this case. Now, why is it that it goes on to take place in the deserts? Now, cloudbursts can happen in the deserts due to enhanced convection. It's convection aided localized heating of the air. That means it's the air that has been heated. Of course, it has been heated and it goes on to convect. It is this convection that allows it to rise. And this happened twice, at least twice. This is going to be one of these best examples. And the two of these conditions where it took place had been in different places and in different regions. So one of them had been in Barmer floods that we're going to be calling it. This had been in Barmer floods of 2006, which was a case and which was triggered by unusually heavy amount of rainfall that took place. And then 2020, last year only, it was in Banswara region. That was a case study. Now, cloudbursts in this case can also go on to happen when hot water mingles into the cold, resulting in a sudden condensation. Supposing that above the air would have been cooler. In this case, the air would have been cooler. And if the air was rising, then there would have been a sudden mingling of it. And this sudden mingling would have allowed all of this moisture-laden winds or moisture-saturated winds to fall, and fall suddenly as well in this case. That is why it takes place in the deserts. These cloudbursts, of course, they go on to lead to a lot of destruction, and destruction goes on to take place because of many reasons. The frequency of such type of a cloudburst that have been taking place had been very, very different. But we do not go on to know about a lot of cloudbursts taking place because of many conditions, many reasons. One of them is that there are going to be some of them only which are going to be counted, only some of them that are counted. And why? Why is it that some are counted? Because of the reason that some of them can go to take place in remote areas, in remote regions where such type of data is not normally available. That is going to be one factor. That's one. That's why this destruction is not going to be counted at all. That's condition number one. Second is events of extreme precipitation have been taking place and have been increasing over the last decades or so. That means every year there is something going to be very, very different. And because temperature fluctuations are going to be on the rise, this is the basic reason that cloud burst type of events have been increasing as well, and they have been increasing at a faster pace too in this case. Now, all of these cloudburst events that are taking place, they have a certain type of a mechanism by way of which they can be forecasted, and the forecast they can go on to take place. Of course, it is not going to be easy. The difficulty is going to be arising out of the fact that the place where they're going to take place is a very small area, and that's not easily decipherable. That's one. What can you forecast? It is heavy rainfall. Not exactly that a cloud burst can be forecasted. Even in Kedarnath, what was forecasted was that there will be very heavy rainfall. Not exactly that there will be a cloud burst that will go on to take place. a spell of heavy rainfall that is going to be taking place because of the convergence of many meteorological conditions. So had it been, let's say there have been 2 or 3 conditions, then it would have been easy. And consider Kedarnath. How many conditions? Southwest monsoon, that was one. Second was the moisture in the air. The third was the amount of moisture carried. The fourth was how much exactly that it rose. The fifth was how much it went on to cool. And the sixth was as to what extent was it going to be sucked. And because of all of these factors, cloudbursts are not going to be easy to be forecasted. Forecast for a small area can be done through the use of the Doppler radar, and through them it is possible to forecast the possibility of a cloudburst about 6 hours in advance, and sometimes something like some 12 to 14 hours in advance as well in some of the places. But this has been this is something that is still requires to be perfected of sorts in this region. We go on to forecast that there has been a rainfall or a heavy rainfall and so on. Whether we are able to forecast it or not, there are certain effects that there is no way that we can go on to control it. The effect is going to be really daunting, and one of these effects in this case is going to be associated with what we're going to be calling it as a death, destruction and flash flood. Flash flood is going to be the most important. And why is it that the flash flood can go on to take place? A flash flood can go on to take place because of some very obvious conditions. Now imagine the amount of rainfall taking place in a region exceeds by 10 times or 15 times. Now the channels of the river, the channels of the water body that are present in that region, that are existing in this region, they have a limited means of carrying that much amount of water. Now unable to carry that much amount of water, what they're going to do is that they spill over their banks. That's one. And not only that, the water flows with a greater amount of rapidity, and not only is it that it goes into flow with rapidity, the volume of water that is going to be carried, that is also going to be very, very high. With so much amount of water being carried, what this water goes on to do is that when it goes on to come in contact with anything that is lying loose on the slope, and in the Himalayan region there are going to be a lot of regions that are going to be loose. And why they have been loose? They have been loose because they have been blasted loose because of the construction activity taking place in the Himalayas. There is construction of roads, construction of what we're going to say, that is tunnels in this place, Char Dham, all of this, they have been blasted. And because of this blasting, they have become loose. Not only that, there had been deforestation. Not only that, there had been construction of hydropower plants as well. Not only that, that is most of the people who have been displaced from their region because of maybe some construction activity, they go on and occupy certain places and they start depending on vegetation. Vegetation is going to be the main factor. And then they chop off trees because that's the only way that they can go to survive in those areas. So combination of all of these factors will go on to lead to huge chunks of rocks being pried loose, and they're going to fall down the slope. And as they're going to falling down the slope, will going to entail that as they're going to fall down, they're going to pick up more stones, and that is going to be a landslide. These big stones, very, very large stones, whenever they're going to strike against any object, they also going to take a rally of stones with them, and that is a landslide. And also understand, with so much amount of water moving, it is easy that all of this mud and soil on the slopes, that goes into become mudding, and that will go to lead to mud flow, like what happened in Leh and Ladakh, because that was devoid of vegetation. In any area that is going to be devoid of vegetation, such type of mud flow can go on to take place. Now this type of a flash flood is able to excavate some features from the land, from below the surface of the ground as well, and because it is able to take out some of these things, it will go on to lead to the land caving as well. And not to say that all the houses will be washed away, and most of those things that are going to be washed away, what it will go on to do is that it will go on to fall in the channel of the main river, and because it goes on to fall in the channel of the main river, it will go on to block its path. And when its path has been blocked, then it will go on to rise. It will go on to rise, and as it goes on to rise, then after some amount of a time, the accumulation of water can go on to be to such an extent, it will go on to break the natural dam, and that will go on to lead to a flood. even as devastating or even more devastating than what exactly that one can go to think of. And that is what has been happening this time in Himachal Pradesh. This is what has been happening in places like that of Kashmir. This is what has been happening in Uttarakhand as well. And all of these factors have been aided by that of cloudburst. Cloudburst have been almost synonymous to formation and generation and the genesis of such type of landslides and mud flows as well. Now, the only way we can go to say that we can go to control it is going to be something associated with maybe the awareness of the people in this case and associated with some of these type of government measures as well, and an increasing awareness among the people from outside the state as well, so that they don't go to do anything nefarious whenever they're going to go to hill stations essentially to enjoy the hill station. But that is all in all a different chapter, a different talk, and a different session.
To have more such discussions and analysis, subscribe to our channel and hit the bell icon for notifications on our upcoming videos.